Hello students, welcome to Armaths classes. Today we will solve some more numerical problems on Laplace transform. So let us start today's section. Today's first question is Laplace transform of t into e raised to minus 3t into cos 2t. Let us see the problem carefully. Here both the two properties, that is replacement property as well as differentiation property, is holding good for this problem. So we have to apply both of the properties in this problem. So first consider f of t such that it is easy to find Laplace transform. Okay, I feel according to me, first I will consider differentiation, then replacement. It is easy to us. Other than first replacement and then replacement, it is some lengthy process. So first I will consider e raised to minus 3t into cos 2t, that is f of t, because we first deal with differentiation and then replacement. Okay, first tell it as f of t. Laplace of f of t, that is equal to Laplace of f of t means t into cos theta, that is t into cos 2 theta, t into cos 2t. Okay, here property is holding, that is t raised to n into f of t. I call it as g of t because f of t is I consider here, so I call it as g of t. Okay, then Laplace of g of t. What is g of t? Laplace of g of t means Laplace of cos 2t. Cos 2t, according to the standard result, Laplace of cos 2t means s divided by s square plus 4, that it is called as g of s. Okay, then Laplace of t into g of t called that is according to the property minus 1 raised to n d raised to n divided by ds raised to n g of s by the property, that is the differentiation property. Here g of t means cos 2t, that is equal to minus 1 raised to here t raised to 1 is there, so n is 1 d by ds of what is g of s. G of s is s divided by s square plus 4. Okay, minus as it is differentiation of here we apply u by v rule, that is quotient rule. It becomes denominator as it is, denominator square s square plus 4 whole square, in the numerator denominator as it is, and differentiation of numerator, that is differentiation of s is 1 minus numerator as it is and differentiation of denominator, that is 2s. By simplifying this we get x square plus 4 minus 2x square, here s into s is 2x square, and then minus as it is x square minus 2x square is minus x square plus 4 as it is, in the denominator x square plus 4 whole square as it is. Okay, then f of t, that is equal to minus plus x square minus 4 divided by x square plus 4 whole square, that is called as a f of s. Okay, let us put the value of f of s in the equation 1. We get Laplace transform of e raised to minus 3t f of t, that is f of s, where s is replaced by s minus a, that is this is called as a replacement property by the property 1. Okay, Laplace transform of e raised to minus 3. What is f of t? According to us, f of t is t into cos 2t. Okay, t into cos 2t. And what is f of s? X square minus 4 divided by x square plus 4 whole square. Here s is replaced by s plus 3. Why s plus 3? In place of a minus 3 is there, so s plus 3 it becomes. So wherever s is there, replace it as s plus 3. We get s plus 3 whole square minus 4 divided by s square is there, sir, s plus 3 whole square plus 4. That whole square is the final answer. So second one, Laplace of t raised to 5 e raised to 4t cos hyperbolic 3t. Let us simplify. According to us, we know that cos hyperbolic ax, that is standard formula is there, that is e raised to x plus e raised to minus ax divided by 2. In place of a here 3 and in place of x here 3t is there, so it becomes e raised to 3t plus e raised to minus 3t divided by 2. Okay, here Laplace transform of t raised to 5 e raised to 4t e raised to 3t plus e raised to minus 3t divided by 2. So multiply t raised to 5 e raised to 4t, inside we get 1 by 2, t raised to 5 e raised to, here base is same, we add the power, we get e raised to 40 plus t raised to 5, here 40 minus 3t is e raised to t. Okay, 1 by 2 as it is. Consider Laplace to both the terms. We get Laplace transform of t raised to 5 e raised to 70 plus Laplace transform of t raised to 5 e raised to t. Get it? That is called as equation 1. Okay, consider first term, that is Laplace transform of t raised to 5 e raised to 70, that is similar to Laplace of e raised to 70 t raised to 5. Here I consider it as a t raised to 5 is f of t, because transform of t raised to 5 e raised to 40 divided by cos hyperbolic 3t. Here cos hyperbolic 3t is in there, so by the standard result it can be written as e raised to 3t plus e raised to minus 3t divided by 2, 1 by 2 as it is. Okay, t raised to 5, let us multiply the t raised to 5 e raised to 40, inside we get t raised to 5 e raised to 70 plus t raised to 5 e raised to t. 1 by 2 as it is. Let us multiply Laplace individual term, both the terms. We get Laplace transform of t raised to 5 e raised to 70 plus Laplace transform of t raised to 5 e raised to t. That is called as equation 1. Consider first term, that is Laplace transform of t raised to 5 e raised to 70. This is similar to Laplace transform of e raised to 70 into t raised to 5. That it is called as f1 of t. Okay, because f1 it is easy to solve. Laplace of f1 of t, that is equal to Laplace of t raised to 5. Laplace of t raised to n is, n is a positive integer, n factorial divided by s raised to n plus 1. Okay, by the result it gets here n plus of n, here 5 is there, 5 factorial divided by s raised to n plus 1, that is 6. It becomes 120 divided by s raised to 6, that is called as a f1 of s. Then put the value of f1 of s here. What is, by the property, that is replacement property, I can written as Laplace of e raised to 70 into t raised to 5, that is equal to f1 of s, where s is replaced by s minus 3. Okay, what is f1 of s? 120 divided by s raised to 6. Here s is replaced by s minus a. What is a? Here 7 is there, so s minus 7. So 120 divided by s minus 7 whole raised to 6 is the first equation, that is called as a. Let us consider a second one, that is Laplace transform of t raised to 5 into e raised to t. Here also I consider the t raised to 5 as a f of t, that is f2 of t. It becomes Laplace of t raised to 5 is 120 divided by s raised to 6. Here we did that, 120 divided by s minus 7 whole raised to 6. 120 divided by s raised to 6, that is called as f2 of x. Then put the equation, put in equation, so it becomes Laplace of e raised to t f2 of t, that is equal to f2 of s, where s is replaced by s minus a according to the property. Here what is the value of f2 of t? E raised to 5 is there, so f2 of s means 120 divided by s raised to 6. Here s is replaced by s minus a. Here is 1. Okay, so it becomes 120 divided by, wherever s is present it is replaced by s minus 1, it becomes s minus 1 whole raised to 6. Then equation 1 reduces to 1 divided by 2, 120 divided by s minus 7 whole raised to 6 plus 120 divided by s minus 1 whole raised to 6. Here in the both the term 120 is common. By taking common 120 divided by 2, 120 divided by 2, it becomes 1 divided by s minus 7 whole raised to 6 plus 1 divided by s minus 1 whole raised to 6 is the final answer. So next question, Laplace transform of t into e raised to 3t minus 2 into sin 3t divided by t. Okay, that it called as a equation 1. Here then let us multiply Laplace to the both term. It becomes Laplace of t into e raised to 3t as one term, and another term Laplace transform of 2 into sin 3t divided by t. Okay, it is called as a equation 1, not this. Okay, it is called as a equation 1. So first consider this term, that is Laplace transform of t into e raised to 3t, and e raised to 3t is f1 of t. Okay, and then Laplace of f1 of t is Laplace of, what is f1 of t? E raised to 3t. Okay, Laplace of e raised to 3t is 1 divided by s minus a. It is called as a f1 of s. Then Laplace of t into e raised to 3t according to the property minus 1 into d by ds of f1 of s. What is f1 of s? Minus, as it is, d by ds of f1 of s means 1 divided by s minus 3. Okay, 1 divided by s minus 3. By differentiating this 1 by s minus 3, we get, because according to the standard result, differentiation of 1 by x is minus 1 by x square. Okay, and differentiation of x here minus and minus, because differentiation of 1 by s minus 3 is minus 1 divided by s minus 3 whole square, minus becomes plus. Okay, and this is the Laplace transform of t into e raised to 3t, that it called as a equation 2. And consider the another term, that is Laplace transform of 2 into sin 3t divided by t. Let 2 is a constant and it take outside, so it becomes Laplace transform of sin 3t divided by t. It is in the form of third property, that is Laplace transform of f of t divided by t. Okay, here what is the f of t? Sin 3t. Here I called as a f2 of t, because I consider previous term, that is f1 of t. So Laplace of f2 of t is Laplace of, what is the value of f2 of t? Here sin 3t is there, so Laplace of sin 3t is, according to the standard result, Laplace of sin 80 means a divided by x square plus a square. In place of a, here 3 is there, it becomes 3 divided by x square plus 9. It is called as a f2 of s. It is called as a f2 of s. Then Laplace of sin 3t divided by t, according to the property, it is given as a integration from s to infinity f2 of s ds. Okay, what is the value of f2 of s? Here 3 divided by x square plus 9. Here 3 is common, therefore I taken outside from the integration, so it becomes 1 divided by x square plus 9 ds. So we know that integration standard property is there. Integration of 1 divided by x square plus a square can be written as 1 by a tan inverse of x by a. So here in place of x, s is there, and a 3 is there. Okay, 3 as it is. Integration of 1 divided by x square plus 9 is 1 by 3 tan inverse of s by 3, and limits are s to infinity. First we put the value of that is higher limit, upper limit. It becomes tan inverse of infinity minus tan, by applying a lower limit, tan inverse of s by 3 becomes, according to the trigonometry table, tan inverse of infinity is 5 by 2 minus tan inverse of s by 3. That is called as equation 3. By equation 2 and 3, equation 1 reduces to Laplace of t into e raised to minus 3 minus 2 into sin 3t divided by t. That can be written as 1 divided by s minus 3 whole square minus 2 into pi by 2 minus tan inverse of s by 3. 1 divided by s minus 3 whole square as it is. We multiply 2 inside. Here 2 to get cancelled, and it becomes pi minus tan inverse of so it is minus 2, sorry, minus 2 into tan inverse of s by 3 is the final answer. Next one, Laplace transform of cos 80 minus cos bt divided by t. It is the one of the important problem it may ask in your exam, so look carefully. Cos 80 minus cos bt, it is in the form of that is third property, that is integration property, that it is called as a f of t. Laplace of f of t, what is the value of f of t here? Cos 80 minus cos bt. So take the Laplace term to individual term, so it becomes Laplace transform of cos 80 minus Laplace transform of cos bt. According to the result, it becomes Laplace of cos 80 means s divided by square plus a square. Similarly, Laplace transform of cos bt means s divided by a square plus b square. That is called as a f of s. Okay, we have by the property Laplace transform of f of t divided by t, that can be written as integration from s to infinity f of s into ds. Okay, Laplace transform, what is the f of t here? Cos 80 minus cos bt. Okay, divided by t, and that can be written as s to infinity. F of s means this value, s divided by square plus a square minus s divided by square plus b square ds. So here it is in the form of standard, means one standard result is there. If you have in the denominator, means f of s, f of x, in the numerator differentiation of the denominator if there, so that is the differentiation of, so it can be written as simply log of denominator. Okay, if we have denominator as f of x and numerator as differentiation of denominator, then we can easily written as integration of f of integration of that function, that is log of denominator. Okay, similarly here so s divided by s square plus a square, in the denominator s square plus a square is there. In the numerator, if denominator differentiation of denominator is 2s, here in the numerator s is there only, so we have lagging 1 by 2 in the numerator, so I can multiply 1 by 2 and divided by 1 by 2 to the both terms. It becomes 1 by 2 s divided by s square plus a square minus 1 by 2 2s divided by s square plus b square. So 1 by 2 as it is, and this integration of 2s divided by s square plus a square is log s square plus a square minus 1 by 2 as it is, and this integration of 2s divided by s square plus b square is log s square plus b square, and limits s to infinity. First we put the value of infinity upper limit in the wherever s is there. So before applying limits, so it is 1 by 2 is common, and it is in the form of log m minus log n. It can be written as log m by n, and limits are from s to infinity. So when we put the value of infinity in the s, wherever s is present, it becomes indeterminate form, that means infinite. To avoid the indeterminate form, so we have take the common s square in the both numerator and denominator. It becomes 1 divided by a square plus s square. Similarly, here in the denominator 1 plus b square divided by square, and a square get cancelled. Okay, now apply the limit. So first wherever s is there, put the value of infinity log as is there, where s square is there, 1 plus a square divided by infinity, anything by infinity is that 0, and plus 1. Here similarly in the denominator plus 1 is there, so log 1 minus, and here wherever s is there, put the value of s, so it is does not change. Take the LCM and becomes s square plus a square divided by a square plus b square. Here log 1 is 0 minus log s square plus a square divided by a square plus b square. Okay, it can be written, it is in the form of, it can be log 1 by 2 minus 1 log s square plus a square divided by s square plus b square. Okay, it is in the form of n log m, that can be written as log m raised to n. So it becomes 1 by 2 log x square plus a square divided by s square plus b square raised to minus 1. By avoiding to avoid the minus 1, we can written as simply a square plus b square divided by s square plus a square is the final answer. Thank you.